This video will be about proportions and similar figures. Similar figures are two shapes that are the same shape but different sizes. So two triangles, but they would have to look exactly the same. Something like this. Whereas if I drew kind of a random triangle, that doesn't fit with these two. So if you had the shape of a triangle, we have triangle ABC, and triangle VXY. We can look at the corresponding sides of these shapes to see if they're proportional. AB is in the same location as ZX, and also we know since 6 is the smallest, 12 is the smallest. That's one of the ways we know it's corresponding. So AB and ZX are corresponding. For BC, that's the middle length. 14 is the middle length. That corresponds to XY. Or AC will correspond to ZY. So we can find what's called the similarity ratio. How much did we multiply by 10 by to get 20, or 6 by to get 12, or 7 by to get 14? Now this one's set up fairly nicely, so it's easy to tell, oh, I multiplied 10 by 2 to get 20, 6 times 2 to get 12, 7 times 2 to get 14. But it may not always be set up so nice and easy, so we've got to be able to find these similarity ratios. But in this case, the similarity ratio is 2. We're always multiplying by something for our similarity ratio, so we're timesing by 2. And if we were comparing the two triangles, we could write this out as triangle ABC is similar. If you write just a squiggle here, that means similar. We do have to go in the same order. We said A to B to C would be the same as Z to X to Y. So Z, X, Y. So that one gave us all three sides, but they may not give us all three sides. Say we have these two triangles, and they are definitely similar. You are told that they are similar. When they are similar, those sides that we can compare together, we can use to set up a proportion. 6 corresponds to x, so we can put that as a fraction. So 6 was from the first smaller triangle, x was from the second bigger triangle. So we have to go in the same order. 8 comes from the smaller triangle, and it goes with 20. They're on the same side, so it goes with 20 on the bigger triangle. So it doesn't matter what order you put these in, they do have to be matching. They have to be corresponding to put them together. Corresponding in the fraction and corresponding top to top, bottom to bottom. 6 to x were corresponding sides, and 6 to 8 were on the same triangle. Once you've set up the proportion though, now you can just cross multiply to solve. 20 times 6 is 120. X times 8 is 8x. We do our opposite and divide both sides by 8. So x equals 15. That means that left side up here was 15 inches. We can also take these shapes and put them on the coordinate plane, which makes it something called a dilation. If you put it on the coordinate plane and make it smaller or bigger, you're doing what's called a dilation. So enlarging or shrinking a picture on the coordinate plane. An example. Let's say we have a rectangle with corners at -3, 2, +3, 2, +3, -2, and -3, -2. We want to perform a dilation. So dilation is either going to make this smaller or bigger. And when we do it, it's always going to say that it's centered around the origin. We will only be asked to do dilations that are centered around the origin. If it's not centered around the origin, it's a much more difficult process. Let's say we are centered around the origin and we're using a scale factor of 1/2. So to find our enlarged or shrunk image, we're going to take that scale factor and multiply it by every single coordinate. Every single coordinate will multiply by 1/2. That would give us 1.5, 1. So if we're to graph that, 1.5, 1 is there. That would give us 1.5, -1. So 1.5 down 1. We get -1.5. That's -3 times +1/2. So -0.5, 1. -1.5, 1. And -1.5, -1. So when it has us do a dilation, we're basically just multiplying. We just multiply by a lot of different sides and points. The next thing we can do with proportions is word problems. Let's say we have a flag, and we don't know how tall the flag is. Remember, when we don't know something, we give it a variable. We're going to call it x. We don't know how tall the flag is. We do know the shadow of the flag is 12 feet. And then we know that there is a person standing there who is 5 feet, 6 inches. And their shadow is 4 feet. So really we have two similar triangles here. So we can set up a proportion. We know x corresponds with the height of the person. Now the height of the person is in feet and inches. Everything else is in feet. So we want to change this. We know there are 12 inches in a foot. So if we do 6 divided by 12, then we would have 5.5 feet. So x corresponds with 5.5. Then we started with the 5-pole triangle, so we have to use 12 next over its corresponding side of 4. Once again, once you have the proportion set up, you just cross multiply. 4 times x is 4x. 12 times 5.5 is 66. And we divide both sides by 4, which gives us 16.5 exactly. So the flagpole is 16.5 feet tall. So the last thing we can do with proportions is to work with scales of a map. So when you have a map, something like this, it'll say like 1 inches is the same as 20 miles. This is usually where they use the colon instead of division. You would take out your ruler and measure how many inches it took to get from one spot to the other. So let's say we have a map, and we're looking at 2 towns. Let's call them Springfield and Jensen. If Springfield and Jensen are 4 inches apart, how many miles apart are they? So we have our scale. Our scale said 1 inch was 20 miles. That's going to be one side of our proportion, 1 over 20. Then we're going to take whatever they gave us. They gave us 4 inches and match it up with the inches. So inches to inches is going to match on the top. If it had been 20 inches or something on the bottom, we'd put 4 inches on the bottom. We've got to match it up with the correct units. So 1 inches matches up with 4 inches, and then we don't know how many miles apart we're looking for that, so we use x. And then we cross multiply again and solve. 1 times x is 1x, 20 times 4 is 80. You could divide both sides by 1 to say that x equals 80 miles apart, not feet, miles. So they are 80 miles apart. Anytime you're doing a word problem, always double check and make sure it makes sense. If I said they're 80 feet apart, that doesn't make sense. Towns aren't that close together. They're usually measured in miles. So just double check that as you work through any word problems. So that concludes our discussion of proportions and similar figures.